Hello everyone, my name is Aditya, you are watching WebCoder and today we are going to implement the KNN model. If you haven't watched my previous videos about the concept of KNN model, you can click on the link. If this is your first time on this channel, make sure you watch the whole video, and if you liked it, please share with your friends that want to learn machine learning. You can also follow me on Instagram, the link is in the description. So without wasting any time, let's do it. So here I am in my Jupyter notebook. You can use any editor that you want. So right now I am going to look at classification problem and then I am going to show you regression problem. So starting with classification problem, we have a Titanic clean data set which shows the number of survivors from the Titanic incident. So first step is to import libraries. I have imported pandas, numpy and matplotlib. Pandas for data manipulation, numpy for arithmetic operation, and matplotlib to plot some graphs. And the next step is to load data. So right now I am using pd.readcsv method to load my data set, and I am storing it in a data variable. So it is a clean data set. I have already computed its missing values and performed variable encoding on categorical variable. If you don't know how to do it, you can click on the link to watch the whole video. So let's run it. So we can see there are 891 rows and 25 columns. Let's also take a look at data set. Okay, so here are dependent variable and rest are independent variables. Then the next important step is to separate dependent and independent variables. So I'm storing my independent variables in X and my dependent variable in Y. Let's also take a look at their shapes. Okay, so we have 891 rows and 24 columns in X and 891 rows and 1 column in Y. Now the next step is scaling data. I have already talked about this, how scaling can affect distance based algorithm. If you don't know these issues, you can watch my previous video by clicking on the link. So for that I am using min-max scaler from sklearn.preprocessing. What it does is it scales down all the values in dataset between 0 and 1. Okay, so let's run it. Since fit_transform method returns us a numpy array, we need to convert it into a data frame. For that I am using data frame class of pandas. So let's take a look at our dataset again. So now you can see the age and the fair are already scaled down between 0 and 1. If you see previously, their values are 20 to 7.25, which is greater than 1. So the next step is to split our data into training and test part. So for that I am using train test split from sklearn.model selection. In that you need to pass your independent variable, then your dependent variable. Random state indicates that whenever you use it with a similar value, like I am doing here 56, each time you run this you will get the similar output. And stratify indicates that the classes that are present in your data set are equally divided into train and test set. So let's run it. Now the main part, implementing a KNN classifier. Okay, for that I need to import neighbours classifier from sklearn.neighbours, and to evaluate our model I need f1 score. It is from sklearn.metric. Now first of all we need to create the object of KNN. So for that I am using KNN class, and neighbours indicates the number of neighbours on which our prediction is dependent. So right now I am passing value 7. Then I need to fit my model or train my model using my train data set, which is train X and train Y. Then I need to predict for test cases. Then I need to calculate the f1 score, and finally I am printing it. So let's run this. Okay, so now I am getting an f1 score of 0.66, which is 66%. So it is not great. I need to improve on. So one method I discussed to improve your performance is the elbow method. So right now I am defining a method called elbow. I am passing the value of k. I am initializing the test score list to empty, and for every value in k I am creating an object of KNN with the neighbors equal to I, and then training my data set, then predicting values, calculating f1 score. And since I want to calculate the error, I need to subtract the f1 score from 1 and appending the error to test score, finally returning the test score. So let's run this block also, and right now I am passing the value of k between 2 to 20, saving the result in test variable. Okay, now let's see the graph. So as you can see here, between 12 to 13 the test error is very low. So let's go with a value of neighbors equal to 13. I'm doing the same procedure, just I changed the number of neighbors to 13. Okay, so right now I'm getting a result of 0.70, which is better than my previous model. My previous score was 0.66 and right now it is 0.70. It is not the best score you can get from the model, but by using elbow method we are able to increase our accuracy by 4%. So now let's talk about regression problem. Right now I am using the Big Mart dataset. It is a dataset which tells us the sales of an item. So let's read the data. So it has 8,523 rows and 46 columns. Let's take a look at our dataset. Okay, so right now you can see the item weight, item visibility. So our dependent variable which we want to predict is item outlet sales. Separate out the dependent and independent variable similarly as we did for classifier. We are going to again scale that data. So we are using the same min-max scaler from sklearn.preprocessing. Let's convert the array into data frame and also take a look at the data set. So as you can see, the item weight, item visibility are all these variables are bring down between 0 and 1. So the next step is again to split our dataset into train and test. For that I am using again train test split from sklearn.model selection. If you remember, previously I used stratify. So since in classification we are dealing with classes, we need to use stratify. So it will make the total number of each class in train and test equal. Right now we are dealing with a regression problem. We don't need to specify stratify. And now we need to import kneighbor regressor from sklearn.neighbours. And for evaluating our model, we need to import mean squared error. So I'm doing the same thing, creating an object of KNN, passing the number of neighbors, fitting my object on training set, then predicting the result and calculating the mean squared error. So now you can see our mean squared error is something 1639,285, which is very large. To reduce that, I have again the elbow method for regression. So I'm doing the same thing. Now let's see which value of k is better for regression. So now we have our graph ready and plotted. If you see between 8 and 10, we get the minimum error. So let's go with a value 9. Again I'm using the same thing, creating object of KNN, passing the n neighbors, this time is equal to 9, and just predicting the score and also test calculating mean squared error. Okay, so right now we are getting 1622,957, which is a little bit less than what we have previously here. These are the ways you can implement a KNN model. The code and the dataset is available on GitHub. The link to it is in the description. Make sure you check out that. Right now I'm used just n neighbors parameter of KNN. There are a lot of other parameters that you can play with and increase your model performance. That's it for this video, guys. I hope now you know how to implement a KNN model. If you liked it, please hit the like button, share with your friends that want to learn machine learning, and if you haven't subscribed to my channel, make sure to do it. And if you have any doubts or queries, you can ask me in the comment box. It is always open. So catch you guys next time. Till then, share knowledge to gain knowledge.